So the first topic which we are covering is traffic flow theory or traffic, what was the name? Yeah, traffic stream characteristics of traffic flow theory. This is related to this outcome of the course. So your course has 4 outcomes. The slides are related to the first one, the first outcome, which is understanding basic concepts of traffic engineering. Okay. So the term which we use for traffic is traffic stream, okay, or traffic flow, okay, and both are synonymous, okay. They have the same meaning, okay. You have the stream of water, right, and you have the stream of data. Say data streaming, right. So data is doing what? When you say data is streaming, data is doing what? It's flowing, right? It's moving. Okay, that's why traffic flow and traffic stream is the same thing. But that also means that if you are in a parking lot and there are vehicles around you, there are cars, 100 cars. Okay, this is a traffic stream. Yes. Okay. So these things which we are applying are not for these conditions. Okay, they are not on vehicles, they are on flow of vehicles. They apply on flow of vehicles. Okay, so the traffic stream is made up of drivers who are inside the vehicles. Okay. Now we have vehicles which are without drivers. Have you seen them in videos? You have actually used them. No? But they are being used, right? By other countries. Huh? Yes. Not here, right? Okay, mention. So, but even those vehicles which are going without drivers, they follow the same rules. Or we expect them to follow the same rules. Okay? With more accuracy of the speed. Without drivers. They are more accurate, right? No? Who told you? Obviously, they are more accurate, right? In terms of what they mean, more accurate. Like as a driver, your speed can vary more as compared to a car without driver. Agree? Okay. Whether it's too high or too low, that's another case. Okay. But the variation with the driver is more, right? The variation with the driver is more. Okay. So they could be more accurate, okay, and they could be more efficient, but the rules will not change. The principles will not change. Okay, the signal is red. If the car is without driver or with driver, stop. You want to change the lane, you have to follow the same rules. The driver has to follow. Okay, but obviously the driver. Okay, depend upon them. But the point is. The equation which we will discuss for traffic streams, the conditions, the rules, they apply. Okay, so even vehicles without drivers will have the same conditions. Conditions will remain the same. Values can change. Get my point? The values can change. Okay, the conditions will remain the same. Okay. So these vehicles, when they are moving on the road, we have talked about traffic stream, right? It's moving. So the movement depends upon two things. Oh, sorry, not two, three things. The movement depends upon three things. Okay. Other vehicles, road design, and the environment. The movement of vehicles, how it is happening, depends upon three things. Other vehicles, road design, and environment. Okay. If you have more vehicles on the road, the speed will be okay. Similarly, for lane changes, there will be more delays, right? And so on. So this is happening because of other vehicles. Then we have the road design. So you are going on the road and there is an intersection. Okay. You have to stop. There could be a queue as well. There will be delay. Okay. And so on. So this is road condition affecting your flow, your movement. And then we have the general environment. Okay. So today in the morning there was a problem, right? No problem, we were sleeping. Right? Not sleeping. Like around 7 o'clock. Did you see? How was the weather? You were sleeping. So when I said morning, you had like 10 o'clock in the morning, right? 9. Okay. There was a fog, right? Okay. So on the same road with the same capacity, because of the fog, people were going slow.
Yes.
Okay. So this is the effect of the environment. You have rainfall. Maybe the rainfall is not heavy. The rain is not heavy, but the roads are wet. Okay. So this is happening because of the environment. Okay. Another thing is you have trees beside the road. You have big buildings. These are also part of their environment. Okay. Studies have shown that they also affect movement of vehicles. They also affect movement, although they are not on the road. The way people are going mad after the environment, you may have some trees on the road as well, but not till now. Okay, the trees are on the side, the light pole is on the side, the building, but still these things affect. Okay. One thing which is very common are the billboards, right? With the offer, offer, new app. You know that, right? You want to go through marketing. So I'm coming to university and there's an offer there. And that's it, right? Okay. Now, if you collect traffic data and you compare it, it will not be the same. If you do it on the same road at different times, you'll get different values. If you do it on 2 different locations at the same time, you'll get different values. Okay? So traffic flow or traffic data does not remain the same. Okay? And they have identified a couple of main reasons for this. One is the change in vehicles, variation in vehicles. So you have some times where the school buses are more common in the traffic. Then you have some other times where trucks are more common. Okay? So this changes the traffic a lot. A truck doesn't move in the same way as a car. Okay? And then there are other times where the bikes are very common. Okay? On the weekends there are some roads on which you will see the line of bikes. Okay? So these things will affect how the other drivers are moving. Because traffic flow is what? It is affected by other vehicles as well, right? Okay, so if other vehicles are changing, your behavior will also change. Okay, and then I told you about drivers are drivers. They don't behave in the same manner. Okay, it's not like a driver who has stopped on the yellow light now will do the same thing on every yellow light. After the first one, you will start feeling stupid, right? Yeah, why did I stop? Or others behind you will make you feel. What did you do? So, and that also depends upon your time, your mood, where you are going, for what purpose you are going, and so on. Okay? So, going to the exam and coming from the exam is not the same, right? So, that also changes the traffic flow. These are 2 main things which affect traffic flow characteristics. You have taken 331 and 331. We have talked about different types of highways. What? Local character and RT, right? What do we call this classification? There is a name for this classification. We can classify in different ways, right?
Yes.
So I can classify the students in the classroom in terms of their batch. I can classify in terms of their gender, classify in terms of the area that they are living, right? Speed limit? Sure? No. Okay, they are classified on the basis
Their
of.
locations
No.
and their
Location is a part of it, yes, but we didn't talk about it. Okay, we said RT will collect and
there's
you didn't
urban
say.
and
Yeah, so you didn't say. Okay, yeah, that's nothing. But anyways, even with the location, that classification is based on function of the highway, the purpose of the highway. We call it functional classification. Okay, but the highways can be also divided on the basis of traffic flow. So yes, when you are dividing it according to the function, then speed limit plays a big part. Because according to the function, you decide the speed limit. Okay, or the design of the road. Okay, so the first step in the design of the road is knowing its classification, functional classification, functional. But then there is another classification which is on the basis of traffic flow. Okay, on the basis of traffic flow, we have two types. Okay, we have uninterrupted, we have interrupted. So here we are not talking about location, we are not talking about purpose of the highway. We have obviously the purpose will affect traffic flow, but the classification is not on the basis of that. So on the basis of traffic flow, we can have uninterrupted flow or interrupted flow highways. Interrupted flow highways, uninterrupted flow highways. Okay. The main difference is on uninterrupted, we don't interrupt the flow. On interrupted, we interrupt the flow.
free flow. The first one is a free flow.
No. Free flow is a condition, not a type. Okay. So where do we, like not we like not me, okay, or we like universal diamond, we like traffic engineers, where do we interrupt the flow? Where do we stop it? Traffic flow. Like we have traffic flow which stops because of some accident, because of traffic jam. This is not we doing it. But where do we do it as traffic, as highway engineers? Where do we interrupt the flow? On intersection, right? So this is the main difference.
To distribute the flow.
Yes, distribute or where you have a conflict in the flow and you have to stop them, right? For safety purpose, you have to stop. Okay. So this happens at the intersections mainly. There are other cases as well. Okay, I will show you. But you get the idea. On intersection, you have to interrupt the flow because there is some conflict with some other traffic. So you are interrupting one highway to allow other flow to move. Very much. So this is called interruption. Okay, and we are talking about that interruption which is caused because by the design. Okay, not because of an accident, not because of traffic jam. Okay, or not because two drivers are fighting each other. Okay, so that interruption is first of all not part of traffic flow itself. The flow can move, but we are interrupting it, right? So this is external. External, like from the design, from the person who designed. He designed that the flow should be interrupted at this location, no matter what. Okay, so it's external. Second one is, it's not written here, but it's permanent. Okay, it's permanent. It's not like it will happen now, and next time maybe I will come, there is no interruption. No, the interruption is there. Okay, so highway which does not have an interruption by design, we call it uninterrupted. Okay, so that highway mainly does not have any intersections. Because if you put intersection, then there is an interruption. You cannot have intersection without interruption. So a highway which has intersection cannot be uninterrupted. It has to be interrupted. Got it? Okay. A highway which has no interruptions, no external interruptions. Another terminology for them is having full access control. Okay. This access means entry. Okay, entry. Control control means is block. Okay, control means is block. You go to the airport, you will see signs. Okay, luggage control, passport control. Controlling means they are stopping it. Okay, so on these highways, uninterrupted highways, they are uninterrupted. That means the other is blocked. Okay, so they have to stop for them. So they are uninterrupted, the others become interrupted. If somebody is crossing these highways, okay, you will not let them cross because then this highway has to be interrupted. Okay, so that's why the term which is given to these highways is full access control. Okay, the access, direct access is controlled, blocked. Okay, got my point? Okay, so we have uninterrupted highways. We do not have interruptions by design, so they have full access control. Anybody entering the highway, they don't have the priority. Okay, so uninterrupted can be further divided into 3 different types. We have rural 2-lane highways, we have freeways, and we have 1-lane highways. Okay, and we will talk about each one of them later on. But there are subtypes for uninterrupted. But okay, and then we have, so on uninterrupted highways, you see the pure traffic stream. What was the pure traffic stream? This thing. Vehicles affected by other vehicles, by the road design and the environment. Okay, the classical traffic stream parameters we have. Then we have the interrupted flow highways. So those do not have interruptions, these have interruptions. And those interruptions are fixed and external. They are fixed and external. External I told you because they are not happening because of the traffic flow. They are happening because of design. Okay? And fixed, we don't remove them. Okay. So there is an intersection here, there is an intersection. Okay. It's not like, okay, I was coming at this time, I had an intersection, maybe after 1 hour it will go away. We wish, but it doesn't. Right? But in the other case, maybe there was an accident on the highway now. After 1 hour, on some other day, same time, there will be no accident. Those interruptions are not, they will not change the type of highway. You're getting my point? The interruption which is temporary will not change the type of highway. It's just a condition on the highway. But, okay, it's just like the course. Okay, I'm supposed to teach you traffic engineering, right? But I will say a lot of blah blah in the course. But that's a condition. Okay, but course is still traffic engineering, right? Okay. So interruptions, I told you, interruptions can be intersections. So on intersections, we sometimes have signals. Sometimes they have a stop sign. Sometimes we have a yield give-way sign, the triangle. Yeah, that thing. Okay. The yield sign. Some of the intersections don't have anything. It's an intersection, like many times you see on the local streets. Okay. On the small streets, they don't put any sign. There are small streets intersecting each other. There is no sign, but it doesn't mean it's not interrupted. Because the intersection means the other car is crossing you. It's an interruption. Whether I put a sign there or not doesn't matter. There is traffic from the other side. Got it? Okay, so it can be completely empty, but still an intersection. Okay. Driveways. So it's not a new street. It's just somebody coming out from the driveway, from the parking garage, from the parking gate. That guy is coming, the other guy has to be interrupted. Curb parking. So this is when the parking area is inside the building or the mall or whatever. This is on street side. Okay. Same rule, right? Somebody is going into the parking, coming out of the parking. There is an interruption. Okay. And any other point from which you have land access. I told you the meaning of access. What is the meaning of access? Huh? Entry, right? If there is an entry from anywhere on the road, whether from a parking area, whether from a driveway, whether from a garage, or whether from anything, okay, a construction site, okay, all of them are interruptions. Okay, so interruption does not always mean intersection. It can be something more. Okay, when you are measuring traffic, traffic can be measured by two types of parameters. Okay, so there are two types of traffic parameters, traffic speed parameters. We have macroscopic and we have microscopic. Macro and micro. Okay, you have heard these two, right? Okay, so what is the difference between macro and micro? Like the word, not traffic, macro and micro, like the word. Yes? Micro is small, macro is big, right? Okay. It's the same difference here as well. When we say macro parameters, we are looking at traffic on a big scale. When we say micro parameters, we are looking at traffic on a smaller scale. Okay. Now, I said traffic stream is made of what? Cars, right? This is cars which are moving, right? Yeah, but that's the whole thing, okay? But traffic stream itself is made of moving cars, okay, or moving vehicles, okay? So if you take a group of vehicles together, that is macro. But instead of group, if you take one or two cars or one or two vehicles, at each time it becomes micro. Okay? So macro means big, means the whole flow. Micro means small, means one or two vehicles. Clear? You can see some of the parameters written under each category. Okay? So we have volume, speed and density, and then the other case we have speed, headway and space. Okay? So there is something which is common in them, which is what? Speed. Okay? But what's the difference between this speed and that speed? Low and high? No. Speed of car, speed of road? Anyone?
The number of data that
Yes.
that would change the final result for the
Yes.
speed.
So here we are saying what is speed of individual. Okay. Here it is the full flow. Okay. So saying this one is the speed of the road is somewhat accurate. Okay. But keep in mind, not the design speed. Design speed is not data. Like data we are talking about data you observe on the road. Traffic parameters, data which you observe on the road. So design speed is the speed of the road, yes. Okay, but will I observe it every time? No. Okay, and if I don't observe the design speed on the road, so design speed is 100 kilometers per hour. But now the road is packed, so the actual speed is 5 kilometers per hour. So does this mean the design speed changed? No, the road condition changed. So the speed of the road can be design speed, can be something else. But design speed itself will not change. If I say this road has a design speed of 150 kilometers per hour, it is 150. The design speed is 150. Okay? Okay, we talk about macroscopic parameters. It starts with volume. The definition of volume is vehicles per unit time. Okay, volume is vehicles per unit time. Okay, and that can be taken for passing number of vehicles which are passing a point, number of vehicles which are passing a lane, or number of vehicles which are passing a direction of the highway. Okay, so you can make it very focused, like this on a point. You can make it for the whole lane. You can make it for the whole direction. Okay, you can combine. But in all cases, it is volume. Okay. Now, if you take volume for 1 day or more, we call it volume. Okay, so not 1 day, 1 hour. Okay, if you have done the counting for 1 hour, or more, we call it volume. Okay, so you tell me I observed beakers for 1 day and my count is 30,000. So this is 30,000 per day, right? Beakers per unit time, right? Beakers 30,000 per unit time day. So this is volume. Okay. If you took volume for less than 1 hour, okay, less than 1 hour, like you do for your trial run in the project, you are taking it for 15 minutes, right? So that will not, or just to differentiate between them, we don't call it volume. It still has volume, beakers per unit time, okay, but we give it a different name, which is flow. Right? Okay. So there is volume and there is flow, and the difference between them is their time. Okay, but the time of volume is 1 hour and anything more. Okay, flow is less than 1. Got it? So now for calculation purposes, you will see that often the flow is converted to 1 hour rate. Okay, so your flow was actually 500 beakers in 15 minutes. So 500 beakers per unit, 15 minutes, right? So it is slow. But somebody comes and says, okay, if you got 500 in 15 minutes, how much you will get in 1 hour if flow continues like this? Okay, so you can calculate, right? How? Interpolate. Interpolating this. Multiply with.
We can reach by collecting the data for the road for long term.
Yeah.
So you can.
You will make group with her. You will make group with her. No. No. No.
60 by 500.
60 by 500.
Divided by 15 minutes.
60 by 500.
Do it by mathematics.
Yes, do it by mathematics. What is she saying? Mathematics, right?
Check
500.
500 of we do 500 over 15 minutes equal 500 equal over x. Then خلي x in vectors and x over
Both for the world. There's 500 beakers in 15 minutes. How do you convert it to 1 hour? I did not imagine this could be an exam question in my whole life. I thought this would be easy. Yes.
What's wrong with the calculation?
I don't know. They're doing 60 upon 500. I don't know what they're doing. She is saying I do interpolation. Whatever that is. She is not telling us. How will you do interpolation? Tell me.
500 over 15 minutes.
Yes.
Okay. X over 60 minutes. Cross. Yeah.
Yes.
That's what I'm saying.
That's what calculation.
That's exactly what I said.
You said 60 upon 500.
No,
We
here
say
60
after.
minutes multiplied by 500 because divided by 15 minutes. That's why we are with
I have 2 daughters. So I don't argue with this. They have taught me this the last 6 years. Don't argue with this. Yes, madam. Okay, but anyways, you get the point, right? So in the end, you will get what? Beakers per, after you do this, you will get what? Beakers per hour. Did you observe for 1 hour? Okay, so I cannot call it volume. There is something which is per hour, but not observed per hour. Okay, so we call it what? Flow rate. Okay, get the difference? Okay, so the difference between volume and flow is very easy. Volume and flow is very easy. Okay, what was the difference? What was the limit? 1 hour. Okay, 1 hour more volume, that's an hour flow. Okay, but flow be per hour. Volume can be more than 1 hour as well. But somebody writes volume equals 1000 liters per hour, and he writes flow rate equals 1000 liters per hour. Both of them don't mean the same. Okay, one was actually 250 liters in 15 minutes, which was converted to 1000 liters per hour. So when this guy says the first one, that volume is 1000 liters in 1 hour. That means he did from 0 second till end of 1 hour, and he got exactly 1000 liters. Okay, the other guy, okay, he's doing it on some other height. He's giving the same value per hour, but he did only for 15 minutes. Okay, so the actual for 1 hour, what she was saying earlier, we observed for longer time. So if somebody came from the second highway and he said, I have a flow rate of 1000 liters per hour, there could be another guy who is counting on the same highway, but he did it for 1 hour. Okay, and he can get a value which is more or less than 1000. 250 was only in 15 minutes. Maybe in the next 15 minutes, we have 1000 meters.
It's not constant.
It's not constant. Okay, get my point.
Yes.
Okay. Now, what about the guy who is doing it 15 minutes? He does it for 215 minutes. So he did from 4 to 4:15, he got one value. And he did from 4:15 to 4:30, he got another value. So these two values are different. If I convert them to per hour, I'll get two values of flow rates, right?
Yes.
Are these flow rates in the same number? They are part of the same number, right? They are part of the same number. They are not the same value. Getting my point? You can get different flow rates which are changing not by hour. That's the point. The flow rate is not changing by hour. Flow rate is changing by the time for which you took the flow. If I am taking the flow for 15 minutes, but every 15 minutes I will have a different flow rate. Okay, got it? Okay. Yeah. So we have volume, which is taken for 1 day, we call it daily volume. Volume taken for 1 day, we call it daily volume. Okay? And daily volume is used for documentation, planning. Okay? I want to plan the next highway in the area. Okay? I want to, know the demand of the area and so on. Okay? Future plan and so on. So in this case, we take total for both directions. Okay? For planning purposes, we are looking at the total demand. Total coming into. Okay? The idea behind that is why we are taking the total demand, because when you take a trip, you took a trip to come here, right? Okay, and now after you take the car, you will leave where? All of it, right? So your trip has two parts. Okay, and normally those two parts are coming and going. Okay, so it's easier to calculate total, because I know if I have a university here, how many people will come here. It's easier for me to calculate this, right? Okay. But how many people will be in one direction at one point of time is different. Getting my point? Okay, because you are stuck here with me at 5 o'clock. Other students are not, right? Okay. So to calculate demand, which is separate for up time and separate for direction, is difficult. But to calculate total is easy. But total means that we have to consider both directions. Okay. So this is where daily volumes are used. We are using it for planning. Planning is long term. For long term, total demand is easier to calculate. Okay. For short term, you can have hourly demand, how much in this direction, how much in, if I ask you how much in direction volume for the next hour, it's easy. You can observe it, you can open previous data and all. But the total after 20 years, it's difficult. Okay. So this is where we use daily volume. Daily volume can be of 4 types. 4 types of daily volume. Okay. We have AADT, ADT, AWT, AWT. For all of them, you can see the full form. Okay. So if you talk about the first A in all of them is what? Average. So we have multiple days of data, and we are taking an average to make it per day, right? In all of them. Now the difference between them is for how many days you have taken the data and which days you have taken the data. Right? The difference between them is how long and which days. Okay? So in the first case, how long I have taken the data? Whole day. Which days? All. Second case, okay, average daily traffic, ADT, average daily traffic. How long I have taken the data? Less than 1. Which days? No, there's a problem. Should be all. Yeah. I'll make the change. This one should be all, and this one should be. Okay, so all days but less than 1. Okay, this one AWT, average annual weekday traffic. So how long? Full year. But which days? Only weekdays. Okay, so this one will give me how many days? The first one 365, right? And this one will be less than 365. Okay. Yeah. Can you have the full year without the weekends? No, right? Yeah. The actual data is full year means it had the weekends. Then I took it out. Okay? The point I am trying to explain here is this does not mean that I have taken 365 weekdays. No. But 365 weekdays does not happen, right? It was 365 days like the first one. Then I took out the weekends. Okay? Right? And this one, less than 1 year, only weekdays. Got it? Okay. Okay. A very simple, small example. Okay. So we have to calculate the 4 parameters for this data. Okay. Now what is this data? It's given for each month, and the total is also given. What is given for each month? How many weekdays were in each month? Okay. From where did I get it? The calendar. Okay. You have to open January 2026, and you have to count. Okay. You have to count. So January every time will not have the same weekdays. Okay. And then this one, total. And where did I get it? The calendar. Okay. But this one is all of them, but what else? I don't have to do it every time. Okay. Like January full days are 31.
February,
February, no, obviously. But for most of the it's fixed. Even for February, I know in advance, right? Okay. So this is the total for each month. Total monthly. Okay. That means, and this is total weekday monthly. Okay. So the values in 4, column number 4, are for these days. The values in column number 5 are for these days. Clear? Okay. Now if I have to calculate AADT, AADT was full year, all days. Okay? Full year means all months, right? All months. Okay? For our convenience, this is for each month and this is for all months. Right? Okay? So, and so what, this is my AADT? No. What was AADT? What was the first A? Average. Okay, so we are not looking for total, we are looking for average. Okay, so you have to take an average. Okay, and we will do it later on in some other topic. Keep in mind when we are doing the average for volume, whatever, whichever one. Okay, number of days corresponds to the number of days for which the data is taken. Okay, simple average. Okay, so if the data is for 365 days, then you have to divide by 365. Okay, so what is my AADT here?
This 900. So the total for monthly volume total over 365.
Okay, vehicles per day. Okay. Okay. The second one.
This 900.
No, this one.
Weekdays, only weekdays.
This one. Group work. Huh?
7076.7. So it will be 77.
Okay. What about the other two?
Availability over weekday.
DD.
And
What is it?
13701.
Uh-huh.
4250
We are doing this 2583. This is 2583.
over 260.
Over 260, 260, 260, 260. Yes.
900, 29.4, so
93. Come.
weekdays.
2583,000 divided by 260. 2583,000 divided by 260. How much?
9,910. Yes. It's 9,000.
I'm still not sure.
See that calculation.
2583.
2583 plus 0.
Okay. And okay. What about the other two?
ABT.
Now we are talking about the second and the fourth. Second one. 1, 3. This is what did you do? For January, right? Okay. Now these two, the second A in both of them is annual. So these two are for full year. These two are for full year. So if I give you 1 year data, which is given in this problem, you can only calculate one of these values. You cannot have two AADT with 1 year data, right? Because for each one AADT I need full year, right? Right? Okay. Now for the second one, I don't need the full year. I need something less than 1 year. Okay, so I will look at my data, and if I see my data, I'm seeing that the values are given for each month. So there are 12 values. Okay, and for each of them I can do the average. Okay, for each of them, for each month I can do the average, right?
Yes.
Okay, so in the second case, for ADT and AWT, you can have a value for each month. Okay, so for example, for January, I will do for ADT 425 upon 31, which is what? 13709. Okay, vehicles per day. And for AWT, I'll do 208 this upon 22.
9454.
How much? 94
9454.
and 4. What? Round up. What you? One week. Not even one. Not even one, right? Okay, it's not like they will say, oh, I got one more, now give me one more car. It's not like this, right? Okay, so whatever. So round up, round down. You can go round up, no problem. Okay, one. So if you got F in the exam, it will not be because of not involved. Some of you have this logic. Oh, doctor, if I was rounding down, maybe you give me F. No. Okay. Now, the first two are annual. We have to use the full year data. The second two are less than 1 year. So you have to look at your data less than 1 year, how much time I have. Because for each month I can have for each month a separate value. Alright? Later on in some other topic, we will do it for each week as well. Or not even week. We may select some days and do that. Even within the week. Okay? That will be ADT. So ADT does not have any fixed time frame. Got it? Another thing is if somebody took ADT for the whole year. Somebody took ADT, not AADT. ADT for the whole year. What do you call that?
AATT. It's annual.
Yes.
So, first of all, AATT.
Yeah. You will tell that guy that you cannot call it ADT. Okay. So, and what about if somebody said I calculated ADT for January? Okay. So they are not. You cannot mix them. Okay. So this is the thing. Yes. Okay. Thank you.